So, what is missing in our meta model are, of course, OCL constraints. A meta model is, of course, a model, and one of my main messages in this course was you have to apply OCL when you are developing models, and you have to apply OCL when you are developing meta models. The first invariant that we see over here concerns the data types. It is a naming restriction, and it's quite a simple restrictions. Different data types have different names. We have here an invariant which is quantified, has two universally quantified variables, namely the self, which ranges over all data types, and the self2, which also ranges over all data types. And when self and self2 have the same attribute value for the name attribute, this implies that self and self2 are identical objects, or you can read this the other way around. When you have self is unequal to self2, this implies self.name must be unequal to self.2.name. So this is a simple naming restriction. It forbids, for example, we have here two different objects. One object is called integer, one object is called string. That's the object identity. If you would now change this, the value of this attribute here from string to integer, then the respective constraint that we have seen a minute ago, this constraint, this invariant would be violated. So this is a constraint for the base part. The base part is the part that is common to the ER model. In the upper part we see, of course, the ER model. In the lower part we see the relational model, and there is a base part, a shared part, and there are some constraints, some invariants that apply here to the base part. And this is one of the constraints over here. Constraints for the ER syntax part. The ER syntax part are this part over here, and the constraints that I will show and discuss is here. Well, different ER schemas will have different names. It's a very similar from the structure of the constraint. It is very similar when you have two different ER schema objects. Self and self2 are ER schema. Self is an ER schema object, and self2 is also an ER schema object. And when you have different self and self2 are different ER schema objects, then they have to have different name attribute values. Second constraint, within one ER schema, different entities have different names. The formulation of the formula is a little bit similar, but in this part we do the following. We consider an ER schema object. Self is an ER schema object. Self.entity are all entities which are part of the ER schema, and then we are considering two entities, E1 and E2, and when they are different entities, they have to have different names. Third constraint, entities. The set of key attributes of an entity is not empty. There is in the class entity, we can define an operation key, which gives a set of attributes, and these attributes are those attributes which have the isKey attribute value equal to true. And yeah, the requirement now is simply self.key not empty. So the set of key attributes of an entity is not empty. Intuitively, this means when we have an ER schema object, here we have an ER schema object, so we have to do, every entity has a number of attributes. And by the way, if we look at the multiplicity, an entity there are different versions. An entity can have a number of attributes. We could have, instead of saying star here at this position, we could have set here one dot star. But what the constraint says is at least one of the attributes has to have an underlining here. There is at least one attribute which is attached to an entity, and the isKey attribute value must be equal to true. So this is what this constraint says. The last example on the ER syntax part is the set of key attributes of a relationship is empty. So there is no underlining in the relationship attributes. And there we say explicitly context. The context are the rel-ships, is a rel-ship class. Rel-ship key empty is empty. Self.attribute, that's the attributes of the rel-ship, and we select those attributes which have those attributes A, where A isKey is true, and this set has to be empty. So no underlining is allowed for the relationship attributes. And this rule here, or this invariant, nicely shows that the language design is done here by formulating invariants. Language design in the sense that at this point we are saying when is at which positions is the underlining allowed, and at which position is it obligatory to have the underlining. The underlining, the key attributes are needed for the entities. Key attributes are not allowed for the relationships. So in this sense, you are doing language design by means of developing constraints. Well, a constraint for the ER semantics part. The ER semantics part, that was this here. We have instances and we have links which live in an ER state, and the instances are typed by an entity, and the links are typed by a rel-ship. And the constraint says here in the ER semantics part, two different instances of one entity can be distinguished in every ER state where both instances occur by a key attribute of the entity. So let us look at a concrete case. We have had in our example this situation here. We have here, let's look at the complete object diagram. We have here the Charles instance, and Charles instance, the Charles' passport number is 456. We also have the Diana instance, and the Diana passport number is 123. And in the constraint now requires that the values that are lying behind these value objects, when you have two different instance objects and you are considering the key attributes of them, and the passport is de facto the key attribute, then the value for two different instances, the values of the key attributes must be different. So let's look a little bit at the constraint. Maybe we get the details over there. So self is an instance. Self2 is also an instance. And we have the case that self is different from self2, and self.entity and self2.entity coincide. So self and self2 belong to the same entity, as we have had before. Diana and Charles are both person entities, are both instances which belong to the person entity. This implies, well, we are considering the self is the entity, and self.er state are the states in which the self lives. Self2.er states are the states where self2 lives, and we consider the intersection of these set of states. So S is a state where the self2 lives and the self lives. Then it must be the case, self is an instance, self.entity is the entity of the instance, self.entity.key are the key attributes that belong to self, and there must exist a key attribute Ka such that, and this apply attribute is an operation that takes an instance and applies in a particular state a key attribute, and the operation gives back the value of the key attribute. So when self and self2 are different instances, then there must exist a key attribute such that the value of the key attribute Ka for self and the value of the key attribute for self2 must be different. The two objects can be distinguished by the value of the key attribute here. Okay, so this is an operation that returns the value of the attribute. In the relational syntax is this part over here. A relational database schema consists of a relational schema, and each relational schema has many attributes. And the constraint in the relational syntax part now says, well, the set of key attributes of a relational schema is not empty. Self.key is not empty, as we have had it for the entity. Relational semantics, this is a requirement analogous to the requirement in ER semantics. Here in ER we had the key attributes for the entities, and in the relational part we have the key attributes for a relational schema. Two different tuples of one rel schema can be distinguished in every relational database state where both tuples occur by a key attribute of the relational of the rel schema. I will not go into the details over here. Let's look at a transformation constraint. I will not go into all details here, but I will simply motivate what the content of this more longish constraint is. The content is as follows. In the translation that I've done in the very beginning, I said a relationship is translated into a relational schema, and the constraint in the transformation part, the constraint in the transformation part now says the following. For every rel-ship in the ER schema, there is a rel schema having the same name. The rel ends representing the arms of the relationship are represented by key attributes in the rel schema, and the attributes have the same properties, name, data type, and key property. So roughly the constraint over here says we have a transformation object, and from the transformation object we navigate to the respective ER schema, and in the ER schema there are particular relationships. And for all relationships in the respective ER schema, there must exist one relation, the RS, that's the relationship, and the relation RL have the same name. And for every arm of the relationship, for every rel end, for all relationship end keys, there is one RA, and that's an attribute in the relational schema. The name of the attribute in the relational schema consists of the name of the relationship end together with the underscore, and then the name of the relationship end key. And the data types, so we have here an RA and we have here an RE, and the data types and the key property must also have particular connections there. So the concrete case over, I will point to you what this constraint is about. In our example ER schema, we had the marriage with the wife and the husband as relationship ends for this relationship. And the key and wife and husband are typed as person here. And the key in person is passport. And now let us look at the translated ER schema. For the relationship, marriage, we have two relationship ends, namely wife and husband. And wife and husband are present here, and then there is as names of attributes, and wife underscore passport and husband underscore passport are attributes in the relation that corresponds to the relationship. So we have a relation corresponding to a relationship, and we have the relationship, and we have the relationship ends. And the constraint over here, the constraint, the last constraint, the most complicated constraint probably that we have been looking at. This is exactly the name of the attribute in the relational schema consists of the name of the relationship end, wife or husband, then the underscore, and then the name of the key of the relation, and that's passport. This is wife underscore passport, husband underscore passport is the name, and this is equal to the name in the resulting relational schema. Okay, so this is a part for the key attributes, and this is a part for the ordinary attributes of the relationships. It's a bit, it's not completely trivial, but yeah, I hope that the general idea of this constraint becomes clear. So what is done with this constraint is exactly this constraint specifies the transformation from the ER schema into the relational database schema. So this last constraint said when we have a particular relationship here in the ER schema, then there must exist a rel schema with the same name, and the attributes in the rel schema follow the structure that this relationship has. Okay, yeah, as I said before, a not completely trivial constraint, a not completely trivial OCL invariant. So relax and thanks for your attention.